strikingly similar to Bernoulli, but it's not. And it does consist of inlet point 1 and exit point 2. And the unit on the left-hand side is in what? In SI? The unit? Meters. We call that the head. Pressure head. In meters or in feet. Velocity head or dynamic head, like you did in the crease. And the height change is called gravity head. So that's left-hand side. The right-hand side is new. H sub F consists of what we call the head. Again, head is a measure of length, height, head, meter, feet. Head loss. Head loss. Due to friction. And in 2 or 3 lectures, we will use your second law of thermodynamics. And I know you hate it, right? You're so confused with the second law. But we're going to use second law to answer why the frictional head loss, losses due to friction, is always positive. Because of the second law. Entropy will always go up. Okay? This is a given. Friction is always going up. Questions? Yeah?
Do we assume adiabatic for all of this? Or
that will come later.
Okay.
Yeah, that will be when I divide this equation. The answer is yes, but that will come later. Right? So right now I want to focus enough to cover you to do the homework. So this is a positive quantity. Always. Friction always causes money. You need a pump to overcome friction. This is a very peculiar nomenclature for the first time, so let me explain it. So this is also can be written as H sub S, where the S stands for a shaft, something that penetrates into the flow pipe that can add work or take work out. And the sign for this H sub S, if it's pump, meaning work is added to the fluid, like this 5-hose column, it's negative. If it's turbine, meaning work is extracted from the flow, is positive. Are you with me? Finally, this WS is something you have seen in thermodynamics repeatedly. So this is called also the shaft work, and it's the work of energy per unit mass. Have you seen this in thermodynamics? Energy per unit mass? I bet you. Right? So we will relate this to your thermodynamics also when we derive this equation. So that's a mouthful with a lot of new concept, signs. In reference to this homework, is there any machinery from point 1 to 2? Is there any pump or turbine in this flow system? No. So the energy equation, when you apply that from 1 to 2, will tell you there's no head due to the shaft. And armed with the fact that the H sub F, due to friction, is always positive, you can now make an attempt by using the energy equation from point A to point B and figure out which direction the flow will go. It's not obvious. You can't guess. If you do, half will say up, the other half will say down. But using an energy equation, you will know conclusively which way it will go. Do you see that? Do you understand how to use this equation? Now, as a very preliminary setup, which we'll go into detail when we spend almost a whole lecture going through that, the origin of this equation of energy is the same as what you have seen in thermodynamics, where you draw a control wall, you have flow going in and flow going out, if I assume Q is 0, and the fact that the work, so this L represent the outflow and the inflow. In your thermal force energy equation and the control volume, this is the sign convention. Am I correct? You've seen that many times, and you always assume the work by your control volume is positive, out, and heat into the control volume is positive. So to get to this equation from the energy, you will assume adiabatic for heat transfer. And the sign of this WS is dictated by our contract, which is plus is work done by my control volume like a turbine. A pump, which is what we're dealing with this fire hose, is negative. And that's how all this sign come about from this contract, from this convention. So this is just a backdrop of a much more in-depth derivation that will come later. Yes?
In the energy equation, the z term in the denominator of the velocity head, is that the same as the gravity head?
No, this is the G. I'm sorry. Is it what you asked?
Right. Oh, is it a 2? Is it 2g?
2G, I'm sorry. It's a 2. 2. Well, V squared divided by 2. It's a 2, not Z. Right? So any other question on the nomenclature? G is the acceleration of gravity. Yes. Okay, so use this to do the homework problem for the pipe.